Gigantism is a disease that causes abnormal growth from the overproduction of growth hormones caused by pituitary tumors, or adenoma. Gigantism is diagnosed by measuring the levels of growth hormone and IGF-1 in the blood. Treatment includes surgery to remove tumors and/or medications that reduce the levels of growth hormone or shrink the tumor. The same germline mutation and haplotype causing gigantism was found in 4 different families from Ireland. A mutation in AIP predisposes carriers to pituitary adenomas. AIP is a receptor for aryl hydrocarbons and a ligand-activated transcription factor. A mutant isoform of R304X associated with acromegaly is a protein truncating nonsense mutation that resides in a known hotspot for mutations. AIP is associated with cytoplasmic multi-protein complex in the AHR signaling pathway. Current evidence suggests that in the presence of a xenobiotic compound, the AHR complex assembles, is activated by the hydrolysis of CAMP, and transported to the nucleus where it acts as a transcription factor for genes involved in metabolism of xenobiotic compounds such as cytochrome P450. Approximately 20 interactions of the AIP protein have been described in various studies, although a molecular causal pathway has yet to be established between the mutant isoform and pituitary adenomas. Recent evidence suggests AIP's interaction with 2 phosphodiesterases. High levels of CAMP have been found in growth hormone secreting pituitary adenomas. CAMP is activated in the cytoplasm by adenyl cyclase and is inactivated by PDEs catalyzing the hydrolysis of CAMP and cGMP. AIP recruits A5 to the AHR complex but is unable to do so with the R304X mutant isoform. It is unknown whether the recruitment of A5 regulates local levels of CAMP. 2A, when bound to AIP, have been shown to lower CAMP concentration in the vicinity of the ARH complex, thus inhibiting translocation of the AHR complex to the nucleus. The effects of both PDEs on the AHR signaling pathway have not yet been directly compared. We propose single and double deletions of PDE4 and PDE2 orthologs in the mouse pituitary gland using the CRELOX2 system. We will expose mouse to xenobiotic compounds known to induce the AHR pathway and then measure CAMP levels in the tissue as a proxy for transmission of AHR. We hypothesize that both PDE4 and PDE2 are required for AHR transmission, and therefore we predict both single deletions will have equivalent CAMP levels as the double deletion relative to our controls. Alternatively, they may both individually modulate CAMP levels and work in an additive fashion, indicating that they independently bind to the AHR complex as well as function independently.